Compound interest is defined as the addition of interest to a principal or initial sum of a loan or deposit. In other words, interest on interest. In order to best explain the concept of compound interest, I will be introducing the compound interest general formula and dissecting and explaining its general components. The model for compound interest is A equals P times 1 plus R over N to the NT power, with A being the amount accumulated over time, P being the principal amount administered, R being the interest rate, N being compoundings per period, and T being the number of periods overall. To best explain how compound interest works, I'll be running through a couple of example problems using a fictional banker who will be accepting the initial amounts. In our first example problem, Akili puts $400 into a bank account to use for school expenses, where 400 equals our variable P. The account is then set to earn 15% interest compounded monthly. 12 months per year means that N equals 12. How much will be in the account after 5 whole years? 5 being the T amount. We'll begin by first forming a table of values, filling in all of the values included inside of the equation, aka the variables A, P, R, N, and T, with the problems that we had in the original equation, or in the original problem, word problem. We begin solving this equation by starting with the exponent on the outside. 12 times 5 becomes 60. Afterwards, we move into the parentheses. We simplify everything that's inside of the parentheses until we get 1.0125. Then, using the simplified exponent, we round that and then multiply it with 400, the number outside of the parentheses. In the end, A equals 842.872538878, which can be simplified to $842.87, which is what will be left over after all of the interest compounding is over. After 5 whole years of compound interest, Akili will have $842.87 in her account. For our second example problem, Joseph opens a saving account. The principal amount he deposits is $600. If the account is set to earn 14% interest compounded quarterly, 4 times a year, how much will the balance be after 3 years? We begin to solve this problem by first simplifying the outerly exponents. While this isn't necessary, it does make the problem easier to manage later on. I then go into the parentheses, simplifying everything until I have 1 plus 0.035, which then simplifies again to 1.035. I then use the exponents to simplify the rest of what's inside of the parentheses, and then multiply this by what's outside of the parentheses, 600. Overall, I get A equals 906.6449441. Dresden's overall balance after 3 years will be $906.64. For our third and final example, after 3 years, Emily checks her savings account and finds that her balance is $635.12. If she initially deposited $5 into her account and it was compounded monthly, what was the interest rate applied to her account? This problem is a little bit different from the other ones because we have to find the rate instead, which is a little bit harder. After applying the values of the variables and substituting it back into the equation, we have 635.12 equals 500 times 1 plus r over 12 to the 12 times 3 power. In order to solve this, we first begin by, since it's like a different format, we begin by actually isolating the variable r, since it's not a, which is originally isolated. We do this by dividing by 500 on both sides of the equation, then simplifying the exponent on the outside of the parentheses. We then get rid of the exponent by multiplying 1 over 3 on both sides, effectively removing the exponent. This becomes 1.006667, and afterwards, since the parentheses are then gone, we can then continue our process of isolating the variable. We do this by subtracting 1 on both sides, and finally crossing out 12 by multiplying 12 on both sides to finally isolate r. R in the end is 0.080004, but this isn't the end yet, since what we're looking for is the rate, which is in the form of a percentage. We have to convert the number that we've gotten, or the decimal that we've gotten, into a percentage. So 0.08004 converts to 8.4%. The rate applied to Emily's account was 8.4%.